All right, welcome kids to chapter 4. This is all about transformations, and we're going to start with section 1, which is just about translations. That's taking things and moving them. There is a lot of vocab to start, so you are going to want to turn to page 174 and start working on the vocab. As we do these problems, you're going to want to practice the vocab. So you should have already paused, copied down the vocab, which includes the core concept, on page 174. If you haven't done that already, you better do that and meet me when you unpause. I'm going to switch here. Okay, so I'm going to do numbers 1 through 4 with you on page 174. You are going to eventually turn to page 177, probably reading the examples in between. Remember, it is your education, and doing numbers 5 and 6. Okay, so number 1 has this drawing that goes with it. So I would like you to copy it down. Remember, you got to practice the details. Copy it down like I've done so already. I'm using graph paper just to stay organized for you. You might want to do so as well, but you don't need to. And number 1 says to, this is the bottom of page 174, remember, to name the vector and then write it in its component form. All right, so this vector goes from B to K. So we kind of just write B, K, and then a line in the direction it's going. Remember, from B to K. Okay, remember, just like raise, the arrows are important. And now the component form. You kind of want to think about it as a coordinate, except we're not going to use parentheses. We're going to use these cool things. All right, but we're still going to talk about the x's first. So what happened to get from B to K horizontally, the horizontal component? Remember, we're going to use vocab as we talk. We went left 5 boxes. Left 5. What's the vertical component? Again, vocab is important. We went up 2. So here is the name of this vector, and here is it in component form. Keep in mind, not parentheses. Make sure you know that. If this was a point, I would have parentheses, -5, 2. This is not a point, it's component form. So I have those arrow kind of things, -5, 2. All right, we're going to do some drawing together, so get ready. Number 2, we're going to make a triangle on the coordinate plane where point L is at 2, 2. Point M is at 5, 3. And point N is at 9, 1. And we're going to eventually translate it. I'll write that down later. First, let's do our coordinate plane. Be nice and neat. Use details if you need to. It looks like our highest points, I know we need to go up 6, so 3 is our highest, and we need to go up 6, so 3 plus 6 is 9. I will go up to 10 just to keep it nice and standard. Take the time to do this with me. It's okay that we use extra space for our education. It's kind of important, wouldn't you say? Now, do I need any negatives? Probably not. I'm going to leave the space there. I'm not going to go as far down as you can see. Oops, excuse me, this one was off. Problems with writing in pen. But I'm at least going to go out here, and if we need to use it, we can use it, because it does say to go left 2, up 6, so it might work out. All right, point L is at 2, 2. Now this is up to you. I label my points on the side, especially when I'm doing a video. I don't want it to get too congested over here. Now, when I have the coordinate pair over here with the appropriate name next to it, I still need to put the the name of the point here. If you want to also write the coordinates like 2, 2, you should. If that's what you want to do, you should do it. There's no harm in being safe. M is at 5, 3, and N is at 9, 1. Here we have a beautiful triangle. I didn't put the M in the right place, but oh well, no one's perfect. Okay, so that's just the vertices of this triangle. Ain't nothing special now. We need to translate it using this vector. And you should be thinking to yourself, how do you know that this is a vector and not a coordinate? You should be able to answer that. All right, so let's do that. We got to take every point and we got to go left 2 and then up 6. What's 2 plus 6? It's 8. And this was L, so this will be L prime. All right, so I don't know where to write this. I'm going to write it over here just to make sure I'm on the way. L prime is at 0, 8. L prime labeled here, so it's not too congested. Okay, where's M prime going to be? We got to take M, and we got to move left 2, and we got to move up 6. So 3 plus 6 is 9. And this would be M prime. Parentheses, where is it? It's at 3, 9. I wonder how this relates to that. Something to think about. Where's N prime going to be? N is down here. We got to move left 2. So 9 minus 2 is 7. And we got to move up 6. 1 plus 6 is 7. And we're going to be at 7, 7. Look at how you can even do that without graphing. And I'm just sitting a little far away. I need to look in closer. And that's where N prime. Do not forget to write the primes. Not the same as a prime number, by the way. All right, so let's see if we follow the directions. The vertices L and N are these coordinates right here. Translate it using this vector, left 2, up 6. All right, and it looks like you can check your work. 2 minus 2 is 0, 2 plus 6 is 8. 5 minus 2 is 3, 3 plus 6 is 9, 9 minus 2 is 7, 1 plus 6 is 7. Okay. Don't be afraid to pause and rewind at this point. Okay. Ooh, number 3 has us look up at example 3. And example 3 has a little graph, and it's telling us to write a rule to translate A prime, B prime, C prime back to ABC. Okay, so we don't have much to do here, but we should copy the graph down to get a better understanding of it. When you write it out, you get a better understanding than if you just look at it. And it goes up to, looks like it's going up to 5. You should be graphing with me. Okay. And I'll use green for triangle ABC. And triangle ABC looks like there is a vertice for C at 4, 1. B is at 7, 1. A is at 4, 3. And I'll use purple for A prime, B prime, C prime. A prime looks like it's at 4, 0. C prime looks like it's at, 0, 4. C prime looks like it's at 0, 2. And B prime looks like it's at 3, 2. Now, number 3 at the bottom of page 174 is asking us to translate triangle A prime, B prime, C prime to triangle A, B, C. So how we're going to go from here to here. How are we going to go from here to here and here to here? So let's think of the vector, its direction. So let's use the vector arrow parentheses. And it looks like, let's see, we've got to do the horizontal component first. Horizontal component from A prime to A. So we go right 4. Vertical component next. We go down 1. Let's double check. If it works for B prime to B and C prime to C, we're good. From B prime to B, did we go right 4? 1, 2, 3, 4, and down 1? Yes, we did. And let's just double check C prime, but visually, you probably have a good idea that we're right now. 1, 2, 3, 4, and down 1. Oh, but you know what? I misread it. It doesn't say write it in component form. It just says to write a rule. So wait a second. The rule is, this would be component form. And it doesn't say that. It just says a general rule. Here is a general rule. We're going to take every X and Y from the triangle that we're supposed to start with, according to this problem, it's A prime, B prime, C prime. And what we're going to do is we're going to take that X and add 4. We're going to take that Y and take away 1. And here is your rule translated from component form to a rule, okay? And this is the correct answer for number 3 when it says write a rule. All right, one last one. We're taking our time because we're graphing, and I hope you're taking the time for your education as well. We're going to do number 4, and then you're going to skip to 5 and 6. Okay, number 4, we have a triangle, RST. It has vertices of R is 2, 2, S is 5, 2, and T is 3, 5. Now, directions say to graph, so I guess we're graphing. If you wanted to get a head start and skip the graph to just do the image after translating this triangle, good for you, but the directions still say graph, so there better be a graph with it when you're done. Doesn't look like we're moving far, but I am nervous about not counting to 10. I'm going to count to 8 just to be safe. Default, we really should do 10 to negative 10 on both axes. But you should be writing in pencil anyway. You can always erase and move it more. I guess I gave myself space. And I'll fill in the negative numbers if I need to. Triangle, point R is at 2, 2. Point S is at 5, 2. And point T is at 3, 5. That's a nice isosceles triangle. And it looks like the translation to the image, vocab is important here, is all the X's we got to add 1, all the Y's we got to add 2. So let's see. Let's take this X, let's add 1. Let's take this Y and let's add 2. What do we call it? T prime. Let's take this S. We're going to take the X's, add 1. We're going to take the Y's and add 2. What do we call it? S prime. Good job. And finally, let's do the R. Right 1, up 2, and we got R prime. Keep in mind the color coding is important here. So green is our original and purple is our image. And what else do we need to do? Graph with the vertices and its image. Boom, 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 boom. Okay, well, for completion's sake, let's label them. We got R prime as, let's see if you did it before graphing, X plus 1, 2 plus 1 is 3, 2 plus 2 is 4. Is that what it turned out to be? 3, 4. Awesome. S prime. 5 plus 1 is 6, and 2 plus 2 is 4. Is that what it turned out to be? 6, 4. Good job. And last one, T prime. 3 plus 1 is 4. 5 plus 2 is 7. Is that what it turned out to be? 4, 7. Oh, I was wrong. Not an isosceles triangle. I'm sitting at a very weird angle to my notebook. So yeah, anyway, it is, I'm perceiving it differently, not an isosceles triangle. I can check by the numbers. Anyway, if at any point you need to pause and rewind, especially to figure out how I got those numbers without looking here first, you should do that. Okay. Right now, though, you will need to copy down the postulate, nice word, right? On page 176. And then you are going to read and then skip ahead to page 177, numbers 5 and 6. Okay, it's the only video for chapter 4, section 1 that we need. So you will see me in class.